everybody to the program. We're delighted to be able to take you into a site containing the oldest, most convincing evidence for life on Earth in rocks that are 3.5 billion years old. It's a great opportunity to come and see what you might be looking for on Mars.
We can see rippled sediment, beautiful ripples here, continuing along, and it comes up to the edge and it pinches out against the side of the stromatolite and then continues over here on the other side. Beautiful.
So what we're looking at here in Western Australia are what are known as stromatolites. These are rock features that were precipitated or caused to precipitate by mats of microorganisms that were living at the time, again, 3.5 billion years ago.
So a stromatolite is a physical feature. Usually it's either a dome or a cone-shaped feature. And these are formed when single-celled organisms living together in a colony either trap and bind sediment or precipitate sediment on them. And then these photosynthetic organisms grow up. And so you see these layers that repeat in that shape. Sometimes they branch, sometimes they grow, sometimes they shrink. But what it is evidence of a colony of life from the earliest evolution of life, the earliest fossils that we have.
And these organisms then had their presence here on Earth captured and preserved in the rock record for all of this time. And so what we're looking for are these particular structures that these microorganisms made that are distinct from what geology normally does.
So the greatest thing about Australia is that it has some of the oldest rocks and some of the best preserved rocks for all different time periods in Earth's history.
And it's important for us to come here because what we're looking for here is the oldest convincing evidence of life on Earth. And in our search for evidence of life on other planets beyond Earth, especially Mars, it's important to understand how difficult it is to convince people of what we're seeing here on Earth as being evidence of life from 3.5 billion years ago. And if we're looking for something similar on Mars, it's a much more challenging prospect.
So in order for us to find a biosignature, there are actually 5 stages that have to happen, and all of them have to happen in this particular order. The first is life has to exist. The second is life has to create some kind of a fossil that we can recognize and we can see as unique enough to be indicative that there was something going on there. Third, that fossil has to be preserved immediately or very soon after it's formed. The fourth step is that preservation has to continue for a long period of time. And then finally, we have to find it. So it either has to be eroded or it has to be somewhere where we can look at a rock and recognize that there's a fossil. That is an extremely unique and difficult process to have happen. So there's only a fraction of life that ever existed ever becomes a fossil. It's in fact an incredibly lucky process to go from life living at some point to a fossil that you can find.
And so that's why building that story takes a lot of time and why it's difficult that any one particular feature may not be biological. But when you combine all of these things together, that is what convinces people that what we're actually looking at is evidence of 3.5 billion-year-old life on this planet. So trying to do this here on Earth is difficult enough, and then trying to do it from 100 million miles away with rovers that have cameras and you have to send signals that take a really long time to go back and forth, even more challenging.
Earth and Mars may have had similar pasts, and the more we learn about Earth's past, the more we may be able to apply it to Mars. Now that we're collecting samples at Mars, wouldn't it be unbelievable if we were able to find something that indicated similar things that we're finding here on Earth that indicate, hey, there may have been life in the distant past on Mars.